the logical design of the network. So after discussing a few topics, this was the last one actually we were discussing, and that is developing the network security strategies. So so we discuss how to design or to develop the network security strategies, just to identify the network assets, and then based on that network assets, we have to analyze the security risks which are associated with those network assets. And later on, we design and develop the security plan and define the security policies. So these things we discussed last time. And next, we came to this different security mechanisms. So we discussed about the physical security, because there are a lot of devices which we have implemented in the organization. So we discuss how to provide this physical security for the devices, then the authentication, authorization for these different network services, then the accounting, so which was a kind of important thing. It is the auditing part. So if there is any security incident or any kind of issue, then you have to somehow there has to be a mechanism to collect the data regarding these network activities. So then later on you can analyze them and check the issues or the problems. So that is for the auditing purposes. So we discussed these things last time. And then we came to this developing the network management strategies. So there are different mechanisms, like we have to do the proactive network management. So I think we haven't discussed this thing, I think. So in this case, so we are now we have this network security mechanisms and all the things. And finally, we are coming to the management part. Right. So if you can remember, in the initial steps, we discussed that the network management is important part, and we have actually discussed these subtopics: the fault management, the configuration management, the counting management, the performance management, security management. So we discussed these things before. Now actually we are came to that stage of the network management. So basically in here we have this proactive network management. So which means the proactive network management means we are mainly checking the health of the network when it is working in the normal conditions, right? So basically when the network, the people or the users are using the network in the normal conditions, in the normal working hours, we normally monitor the network, and we check what are the problems in the network, and what are the potential issues that can be occurred in the network. So we check the health of the network while it is operating. And when we are monitoring and when we are checking these things, then we might come across with some potential issues or problems. Then based on that problems, we can provide some solutions for those problems. So before we are getting these breakdowns in the network, so we can provide some solutions for them, right? And so we can optimize the performance of the network, right? And sometimes we can plan the future upgrades. And so if you need to do some upgrades for the network, then this proactive network management is the good place to decide those things. So as the name it says, so we are not reactive, so we are proactive. So reactive means if something happens, then we act upon it and find the solutions. So something like that. But in this case, we are working proactively. So we are monitoring the network, and we search, we are keen for the potential problems, and we do the necessary or the required changes to the network. So in this case, we basically try to collect some statistics regarding the network, right? So sometimes you might have seen some tool, or maybe you are using currently, maybe you are using that kind of tools. You can see the statistics of the network. So just by looking at that dashboard, you can get an entire picture about the network, right? So there are some sophisticated tools like that. So you can get the statistics, and you can do some tests as well, right? So you can do some tests and check the health of the network. So maybe you can check the response time, right? So maybe in a routine you do some tests, so your pre-planned test to check whether the conditions of the network, right? And from that you can collect those statistics and the test results, and based on that you can get some idea about the network. So normally, again, it is better if you can record these things as reports, right? So maybe a monthly report or maybe a weekly report. So anyhow, so if you can keep some record of these values or your test results, then that will be better to keep a full record of the health of the network, right? So that will be easy for you to do the maintenance part, or maybe do some troubleshooting kind of thing, or sometimes you might need to do some upgrades to the network. So in that case, that reports, or the monthly reports, the weekly reports, quarterly reports, whatever the reports might be helpful for you to do that maintenance part or the management part, right? So that's what we are discussing under the network management strategies, right? So so finally, so from that reports, you can check it with your with the goals that we have initially discussed. So whether your network design has provide the intended level of availability, or whether it has provided that response time, throughput, the usability. So you can compare it with your goals and check whether you have satisfied that initial goals of the network design. So if not, you can go through another iteration, like as we have discussed before, right? So you can do some minor changes to the network and try to improve the network, or try to optimize the network. So we have discussed these network management processes before the fault management. So you can remember that we identify a fault, and we have to isolate it, and we have to provide the solution. And again, the recording or the documentation part is there, the configuration management, counting management. So we discussed these things before. So in here, the main part that I want to mention is that proactive network management. So which you do those tests, or the checking part, or the monitoring part, and the recording of the results. So with those the recordings or the results, you can get some idea about the condition or the current working condition of the network, right? So these things, normally you don't need to do this by hand, because there are tools to do those things, right? Even Cisco has some sophisticated tools for this, but the problem is most of the time these tools are a little bit costly. But if you have a very complex or complicated network, then uh, that the management part will be a little bit difficult. So in that case, you can get some support from these different tools. So I think so from today, I'm going to end my part. So from the next week onwards, the Kenneth sir will take over the course. So he will discuss some of these tools, and he'll try to do some practicals as well. So from these different types of tools. right? So that is about the network management. And so when we come to the network management, these different architectures, so as you know, there are different types of devices in our network. So we have the managed device, the agents, and we have the network management system. So that is normally we call it as NMS. So network management systems. So the managed devices are normally the devices in the network. So as example, the routers, switches, maybe the servers, right? So those are the managed device in the network. So this managed device, so uh, uh, so these devices are uh, the devices or nodes which collect collects and store these management information, right? So actually these are the working devices, right? The routers, switches, bridges, hubs, and all these different uh, nodes in the network. So they are the working devices, and they collects these different management information, and they will store them. They keep these information with them. And we have the agents in the network. So these are the softwares. Actually, it is kind of a software which is running inside these managed devices. So these agents, they track whatever the local management information, and they will use the protocols like SNMP, and they will send these management information to the network management systems, or the NMS, right? So we have the managed devices, and inside the managed devices, we have these agents. So those are a very small software, right? So they are running on these managed devices, and they collect this management information, so which you need to check the health of each and every device and nodes. So those information will be stored in the managed devices, and they will be transferred to the network management system, uh, mostly by using SNMP kind of protocols, and sometimes different architectures or different these devices might have their own uh, protocols as well to communicate this management information. But anyhow, these agents will transmit those information to the network management system. So the network management system is again another application, so which basically shows or display you this management information. So you can monitor those things, and sometimes you can control these managed devices from the NMS, and you can communicate with these agents, right? And you can query each and every agent, and you can check the health, and you can check the condition of each and every managed devices, right? So you are in a single place, right? And you can check uh, the the status or the health of the entire network, right? So this NMS has to be a little bit a powerful device, right? So because you need to process all these the management information there, and you have to use some tools, the graphical tools and kind of things to display all these things. So it has to be somewhat powerful device, some powerful workstation. So all this management information will come to that NMS, and it will process all these things, and you can monitor the entire network from this NMS, right? So as I told you, the Cisco has uh, kind of a protocol, the Cisco Discovery Protocol, and the SNMP, the Simple Network Management Protocol. So those are the protocols normally used to communicate this management information, right? So there are a lot of tools which use these protocols and try to monitor the network conditions or the health of the network. Right? So these tools are very important when we are doing this network monitoring, and that we can sometimes we have a centralized uh, node or centralized network management system to do all this monitoring part, and sometimes we might have some distributed monitoring mechanisms as well, right? So there are different tools, and so the selection of this network management tools and protocols, again, it is a tricky part, not a tricky part, but you have to make that decision as well. So what is the tool that you're going to use to these network monitoring, and what are the protocols, right? So again, you have to make that decision. So if sometimes this uh, the vendors might also provide this kind of tools, right? So if you are going for a specific vendor to build or implement the network, then they might also have their own network monitoring systems or network management tools. Then you can go for their these different systems, or else there might be some other tools that you can use, right? So we will discuss some of these tools later on, so especially the Kenneth sir will discuss some of these tools. So again, so that is your part. So network administrator or the designer, the network designer has to think about what kind of monitoring system or what kind of management system is you are planning to use, right? Okay, so that's all about the logical design of the network. So then we can quickly go to the next topic. So that is the physical design. So let me share the screen, and I will share you the slide set. Right. So I think I have shared most of the previous slides as well. So don't worry, I will share all the slide sets with you. Okay, so our next topic is the physical design. So now we have our logical design. So now our challenge is to transform or convert that logical network design to the physical network. Right? So these are the two subtopics that we are planning to discuss today. So that is, first one is selecting technologies and devices for the campus network, and second one is selecting the technologies and devices for the enterprise network. So it is easy to start it with the campus network because it is the scale of the campus network is smaller when you're comparing with the WAN and the larger network. So we'll start with the smaller network, and we'll try to expand it to the WAN and the larger networks, right? Okay, so we started from the campus network. Uh, so again, the physical network design, uh, so that has mainly this LAN part and as well as the WAN part for the campus networks and the enterprise networks. So as I told you before, we are starting from the LAN part, then we are going to expand it to the WAN. So still we are discussing in the top-down network design, and in this case, in the physical network design, mainly we have to take some decisions. We have to make some choices in regarding uh, the cables that we are going to use for the network, and whatever the physical and maybe the data link layer protocols that we are going to use. and about the devices, the internet-working devices that we are going to use for the network. So as an example, what are the switches that we are going to use? What are the routers? And what are the access points that we are going to use? So those are the decisions that we have to make at this point in the physical network designing part, right? So initially in the logical design, we thought of how the devices are distributed and what are the upper layer protocols that we are going to use. And so at that point, the network was kind of a logical thing, right? But now we are coming to the physical level. So at the physical level, we have to take the decisions of what are the devices and what are the devices that we are going to use, and what are the capabilities of the devices that we have to use, and how we do the cabling, right? And uh, what are the access points that we are going to use. So likewise, we have to make some decisions at that level, right? Uh, so as I told you before, so we started with the LAN and later we will go for the WAN. So we'll expand it. Right, so let's start it from the cabling, right? So the thing here is uh, uh, so once you implement the network, right, so let's say you design the network and you implement it, and maybe after a few years, let's say 4 or 5 years, the devices might change, right? So there may be situations where you need that you change the devices or you upgrade the devices. So you upgrade switches or you change the switches because sometimes the switches, the lifetime of the switches might be ended, or the routers. So you swap switches or you change routers. But the thing is, it is very rare that you change the cables, right? Because changing, removing the cables and doing the cabling again is a huge process, right? So because sometimes the cables might be inside the conduit, right? So you are not going to uh, put hands in the cabling, but the devices change, right? So you upgrade the devices, but normally our practice is we are not we are not changing the cables. So what you have to understand here is, so once you are doing this cabling, you have to think that the cables must stay longer than the other devices, right? So they must stay some longer period than the other devices. So that is inevitable, right? Because you change other devices, but you are very lazy to do the cable changes. So normally you don't do the cable changes, right? So which means the cables will stay longer than the other devices. So which means when you are doing the designing, you have to think about it. And most of the time, when you are upgrading the network or doing the network, design the network, then you have to adapt the existing cables, because you are not going to upgrade the cables. You are going to use the previous cables to do the new or to install the new network. So because of that, when you are purchasing the cables or when you are selecting the cables, then you have to think that this might stay longer than the other devices. So you have to purchase some better cables. So you have to think about the future when you are selecting the cables. So that's one point. I think you have this experience, right? You are changing the devices, but normally you don't change the cables, right? So that's normally I think you have that experience, right? So again, the documenting the cables is also very important. Even we have very recent experience. Last week we went to see a network in some organization. So I'm not going to use the names, but we request their network design or the diagrams from them. But the thing is, they have done their diagrams, and so they have plot the existing network, and they have plot their proposed network, but they haven't include the cables, right? So the cabling was not there, so they haven't illustrate their cables, okay, how the cabling has done in their network diagram. So the, the cables are very important. So the documenting the cabling is also important thing, right? So because uh, we have so in their document they have all the switches, routers, the access points, and all the other nodes connected to the network, even the printers and everything was documented. But we don't know which device or which node is connected to which switch. So that is basically illustrated, or that is basically showed from the cables, right? Cabling. So it is not included in their diagram. So then again, we have to instruct them to do that documentation part as well. So that is very important. So document the cabling as well. So uh, you have to document, or you have to show how the cabling topologies are there, right? How you do uh, the cabling inside the building, and how you do the cable from one building to the other building, right? And what are the types of the cables that you have used, and length, especially the lengths are important, because when you are giving the contract to the third party, so normally they give you the values for the lengths, right? So the length is very important in your document or in your diagram. The lengths are important. So whoever the third party who does the cabling, so normally the cablings will be done by most of the time it will be done by a different party. So they will bill you for the length of the cable. So lengths are important. Then you have to document, or you have to show all these uh, what do you call the location of all these closets or the cabinets where you are planning to keep all the devices, right? And how you do the what do you call this vertical cablings, right? That is between different floors. How you do the vertical cabling, and how you do the horizontal cabling, that is within the floor. How we are planning to do the cabling, and the length, especially the length of the cable. So all these things has to be recorded properly, right? So always, I think from the beginning, I was repeating this. The documentation part is very important, right? So do the documentation properly, because that will help for all the other people, right? Even not only for you, but all the people who are involving in the network, right? So documentation is important, right? So there are different type of uh, the cabling techniques, right, or cabling specifications introduced by different vendors, right? So I'm not going to discuss all those things there, but just remember that there are different cabling specifications, right? Different organizations has introduced different specifications. So how to do the cabling, and some organizations they uh, have given their guidelines, so to follow how when you are doing the cabling, so you are asked to follow those guidelines to do the cabling. So there are different things like that, but normally the people who are doing the cabling, so uh, they know that, right? So they might follow some of these standards, and they will do the cabling part for you, right? So normally this we have generally in abstract way we have two types of cabling topologies, like the centralized cabling and the distributed cabling. So I think I have some diagrams. Yes. So this is some examples of this centralized cabling and the distributed cabling. So in the centralized cabling, it is like a star topology, right? So you are familiar with the star topology. So we have some kind of a centralized device, and the all the other nodes are connected to this centralized whatever the device, and so all the cables will be coming from one point, right? So that is kind of a centralized topology. So you can see it in this left hand uh, uh, diagram. So this is the centralized device, and it has all these wires or cables coming from that particular device. So that is a centralized topology. And we have the other one that is the distributed cabling, right? It's distributed cabling. So in that case, it is not like the centralized one, it is more distributed. So which is uh, like uh, like the mesh topology or ring topology, something like the bus topology. So it is kind of a uh, what do you call a mixed type of topology, right? So both these things, they have their pros and cons. So normally, if your organization is uh, small in scale, then you can go for a centralized scheme and all this centralized topology, right? Because when you have a complex network or a large network, then if you go for a centralized uh, scheme, then it will be difficult for you to do the maintenance, right? So in that case, then you can go for a distributed topology, so which which is easier for you to do the maintenance, right? So you have different pros and cons in these different cablings, but you have to select which kind of topology that you are going to use based on the situation, right? So when you consider the centralized uh, scheme, it is a little bit difficult to do the scaling, right? So when you want to scale the network, or when you want to plug a new device, then sometimes you have to commit from that centralized device, right? So it will be difficult for you to do the scaling. But when you are trying to manage, then you have only one central device, then it will be easy. Not like in the distributed topology, because when you consider the distributed topology, you have different devices here and there. So the manageability will be little bit difficult, but you can easily scale the network, right? So you have pros and cons in this situation, right? So if you consider this diagram, you can see that it has different flows, right? And for each and every flow, everything will be controlled by this centralized whatever the device, right? So that is the centralized topology. But if you consider the distributed topology, you have different devices for each and every flow, right? So the main it becomes a little bit complex when you consider the distributed system, but you can easily scale the network, right? So there are different pros and cons like that, right? So that is cabling, right? The next part is uh, how you do the interbuilding uh, wiring, right? So again, you have these two types. So what I'm mentioning here is abstract idea, right? So the centralized and the distributed. So two abstract pictures, not the different types of topology. So we can have two different abstract levels of this cabling. So in the campus cabling topologies also we have these two types, that is the centralized and as well as distributed topologies. So when you consider the centralized, actually, when you consider this cabling, you have to think about a lot of things, right? So how you're going to lay the cables. So that is the most important thing, because sometimes the people who does not know that there are cables, then uh, sometimes they might dig uh, uh, so there may be people, the working people who might uh, uh, dig, and they might damage the cables, right? They might cut the cables. So you have to think about those things. And sometimes there may be some natural disasters. So maybe if a flooding or a landslide happen, then again the cable might get damaged, right? So uh, these are the problems occur when you are having this interbuilding uh, bias. So that is uh, the main concern that you have when you are doing this kind of cabling. Anyhow, again, the documentation part is important, because where you have put this cable, so you have to have some idea, and you have to follow some mechanisms to protect these things as well. So in this case also, we have two types, centralized and the distributed method, right? So if you consider the centralized topology, as you can see in the top diagram, uh, uh, thing is, if in the centralized mechanism, if something happens to that cable, then there'll be no connection from building A to ABC. So there'll be no connection to anywhere, right? So that is the problem in the centralized uh, topology. So you can see that there's only one cable bundle there, and if accidentally some person has cut these cables, then there'll be no connection for any of the buildings. So that will be a problem. So, but when you consider the distributed cabling, at least you might have some connection by using the other cable. So if let's say the connection between A and B is disconnected, then the building A is somehow connected to the network, right? So that is one advantage of having this distributed topology, right? So anyhow, you have to decide what kind of topology that you are going to use based on the requirement and other things that we have previously discussed, right? Uh, and again, when you have this kind of, when you need this inter-building communication, sometimes the people might suggest to use wireless communication as well, wireless technologies. So again, based on the requirement and the available resources and all the things, then you can decide whether to go for wireless communication as well, right? Uh, so again, in here also we have that the problem, the disadvantage of the distributed uh, topology, where it is little bit difficult to do the management part, right? Because when you're comparing it with the centralized topology, it is relatively easy to do the maintenance when you compare it with the distributed topology, right? So this is how you do the campus cabling, right? So that is between different buildings, how you uh, do the communication, right? So I have discussed some abstract ideas, so how these things happen. But as I told you before, there are different organizations. So they have introduced, there are different standards, right? Or different guidelines to do the cabling, right? So you can follow any of these things and make it in a standardized way, right? So these are just some abstract idea. So remember that we have kind of two methods, that is the distributed topology and the centralized topology. And these two mechanisms or topologies has their pros and cons, right? When it comes to the centralized topology, it is easy to maintain, but it is not that scalable, right? But when you consider the distributed topology, you can easily uh, scale the network, but the maintaining and managing part is a little bit complex when you come to the distributed topology, right? So we have the advantages and disadvantages. Based on the situation, based on the requirement, you can decide what is the topology that you are going to use, right? That is the cabling, right? Then we can, so you have idea about these things, right? But as a designer, you have to have some idea about different cables. The reason is uh, all these cables, all these technologies, they provide different services, right? So based on your requirement, you have to decide what kind of cable is you are going to use, right? So that is basically, so that is mainly onto the requirement and the budget that you have, right? So remember that we discussed the goals of the organization or goals of the client, and to fulfill all those goals, then you have to select the most appropriate cables that you're going to use, right? So you know that this, I have different types. So I have listed some of them: shielded twisted pair, right? Then coaxial cables, the unshielded twisted pair cables, then the fiber optic cables, right? So all these cables, they have their own characteristics, right? And based on your requirement and based on the situation, you can use them, right? So most commonly we are familiar, these days we are familiar with the UTP cables and the fiber optic cables, right? And when you go to the UTP cables, there are different categories, right? So yes, I have got this from a website, so I have put the link as well, right? So you can check this later. And this has an article about these different cables, so you can read about it, right? So you know that this is UTP category, so it has listed I think 9, 10 cable types, right? So normally these Cat1 and Cat2, they are not uh, normally they are not recommended for these data transmissions, and because they don't have that uh, a good uh, bandwidth, and so they don't provide that proper bandwidth with this cable, right? So nowadays, normally we'll go for these cables beyond the Cat3, right? So it has some uh, characteristics of the different cables, right? So Cat3, you can go up to 10 Mbps, right? So it is using for the data transmission, and normally, as I have read, uh, it it is normally used for this voice transmission, but you can use it for the data transmission as well, right? And you have seen that we have different standards, so I don't have it. So have you seen that 10 base T and 100 base TX? So we have different codes like that, right? So you can see that 10 base T, that is uh, some notations that we use to represent these cables and the technology that we are using, right? And then we have Cat4, right? It is better than Cat3. So it is absurd. Actually, it is not common, right? So normally we are not seeing this Cat4 cables that much because we have the Cat5. So after Cat3, the Cat5 has become somewhat popular, right? So it can go up to 100 Mbps. Mm. Uh, so it is normally it supports this gigabit Ethernet, right? Cat5 and Cat5 enhanced. Cat5e means Cat5 enhanced. So that supports uh, the gigabit Ethernet, right? Then the Cat6. So normally these days, Cat6, people are using the Cat6, so 10 gig, right? So these are some standards. So based on your requirement, then you can select what is the cable type that you have to use, right? So the prices changes, right? So you know that the Cat6 will be expensive than Cat5, and I think you have that experience, so that when you take the cable, so you can see the difference, right? So this is Cat5 and this is Cat6. Normally it is labeled, but somehow when you see the cables, you can see it is a different type. So, and again, when you go to the fiber optics, also we have different modes. You can remember we have a single mode fiber optics, multi-mode fiber optics, right? And if I can remember correctly, the single mode is using laser type of light signal to do the communication, and the multi-mode, it is using LED type of communication. So the distances changes. At single mode, you can go up to higher distances, not like the multi-mode, right? Different types of fiber optic cables. So when you're comparing with the other cabling, the fiber optic is little bit difficult to do handling part is somewhat difficult, but you have to consult the people who has that knowledge to work with fiber optics, because unlike the copper cables, you cannot use cable cutters and work with the cables, the fiber optic cables. You have to use that uh, uh, sophisticated tools, especially when you are doing these cable connections and all the things, right? So it is somewhat complex, somewhat difficult. So you need to consult the experts when you are handling the fiber optic cables. Right. So again, based on the requirement and your budget and everything, you have to decide which type of cables that you are going to use. Okay, types of cables. Then we have to think about the LAN technologies. Right. So what type of technology that we have to use, right? So you can see we have full duplex, half duplex, right? So still, if I'm correct, when you go for the switches, it has kind of a full duplex Ethernet, if I'm correct, right? So different types of technologies based on your requirements. So again, you have to think how to use or what other technologies that you have to use, right? So we have 100 M Ethernet, 1 gig, 10 gig Ethernet. So you can go for whatever the technology that you require. So normally what we have practiced is we go for higher rates. So just to provide a good, user experience. But when you try to do that, then it is somewhat costly, right? So you have to spend more to get that experience. So anyhow, with the proper design, what we are trying to do is try to give the proper experience for the users or the performance for the users, and try to reduce the cost as well, right? So that is the importance of having a good design and a network designer, because rather than using the maximum capacity and the all the things, if you can use the the appropriate level of technology, then we can reduce the cost and give the best experience to the users, right? So that is the important part, right? So we have different Ethernet technologies, right? 10 gig, 1 gig, 100 them, then Cisco Ether channel, right? Metro Ethernet. So there are a lot of Ethernet technologies. So you can go for whatever the technology that you prefer, right? Based on the requirement. Right. The next thing is you are going to select the devices. So the internet networking devices for the campus network design. So we had to select, or we had to choose what are the devices that we are going to use. So I have listed some of the devices, the common devices. These are not the manufacturers. So I'm not discussing about the manufacturers because that is something else. So you had to decide who is the manufacturer or the vendor that you are going to select for the devices. But this is just the types of devices, the hubs, bridges, switches, routers. So we have different types of uh, devices. So this is still coming from the OSI layers, right? So you can see that the hub is working in the layer 1, then bridge will be working in layer 2. So 1 to 2 is working the switches, layer 1 and 2, routers from layer 1 to layer 3. So this is basically the OSI layers, right? So if you uh, we can analyze these devices, or we can study about these devices based on let's say the collision domain, the broadcasting domain, and uh, uh, then whatever the other features that they provide, right? So if you consider the hub, uh, the old ports are in the same broadcast domain, right? And they are in the same bandwidth domain as well, right? So if you consider the bridge, so still they are in the same uh, bandwidth domain, and they are in the same broadcast domain, right? If you consider switches, then uh, same broadcast domain, but when you go to the switch, you can have VLANs, right? So which means you can separate them into different broadcast domains. So if you consider a router, so each and every port is a different network, right? So it has different broadcast domains. So the routers, it connect networks, different networks. You are connecting different networks. So if you consider switch and hub, you are not connecting different networks. It is basically you are connecting individual devices. So bridge in the sense you are connecting different networks, right? So likewise, you have different uh, I mean characteristics of these devices. So if you consider routers has lot of additional features, right? So maybe uh, the route it has different kinds of routing protocols, right? So different devices or different operating systems, they have different kind of routing protocols, right? And some routers, they have this access control list and the filtering parts, right? So they have some advanced features like that, you know. And when you go to the switches, so switches also have different switching mechanisms like cut through switching, then store and forward switching, right? Then some of the switches, they have filtering purposes. So a lot of features are there, right? So you have to consider those features when you are selecting these devices. That's why I just go through some of these features of each and every devices, right? And even you know that some of the organizations, so they purchase uh, manageable or main manageable switches, and sometimes the devices, they purchase unmanageable switches, right? So again, based on the requirements, so you have to select what type of device that you have to use, right? Right. And yes, I have listed some of these things, right? So some criteria. So when you're selecting the internet working devices. So as I mentioned there, the number of ports. So that is one thing you have to think. So based on the number of nodes in the network, you have to decide the number of ports, right? Then the processing speed, the amount of memory of the device, the latency, right? So latency introduced by uh, the processing these frames, right? So throughput in packets per second. So we discussed this PPS because some of the manufacturers, they rate their devices using packets per second, right? Then what else? So manageability, right? So that is one thing. So whether they support this SNMP kind of protocols, the cost, again, very important thing. Then how you do the configurations, right? Because some, let's say Cisco, then you have to know the commands to do the configuration, right? So likewise, the easiness of configuring and what are the cables it supports, right? And sometimes this half duplex and full duplex operations. So whether you have to configure those things or whether the device, so some of the devices auto detect all these things, right? So what are the capabilities of these devices? So you have to think about these things and whether they have this packet filtering features, the security mechanisms, and the sometimes you have to think about what is that? The hot swappable components, right? So when you have that kind of features, then the price might go up, right? Then the upgrades, the software upgrades, then the power consumption or how you have to do the power, whether it has this maybe the redundant power supplies, likewise. Then what else? The QoS features, right? And whether you have this technical support from the vendors, right? And whether the devices, they have proper documentation. And sometimes the vendors, they provide you some training, right? So that is another key factor, right? So once they put new devices, they give you a training. So when you are purchasing devices, you can think about those things as well, and especially the reputation of the vendor, right? So you have to think about the vendor as well. So before purchasing the devices, right? Uh, so when you uh, yes, I have put some criteria which you have to think about when you are selecting the switches or bridges, right? So I have mentioned that what are the protocols it is using, right? So the span entry protocols, the VLANs, so how they do the VLANing, right? And when it comes to the VLAN, whether it supports the what do you call that, VLAN trunking protocols, right? So those kind of things, and security, right? Uh, so when you come to the switches, so there are a lot of security issues, right? So we'll discuss some of those security issues in next semester when you go to the network security part, right? So whether the switches and all these things support all that security things, right? Because uh, when it comes to the switches, you have that there are a lot of security problems related to the switches, right? So how you try to provide those things, right? Provide the security, the uh, so we'll discuss them later, right? Uh, so when you're selecting the switches and bridges, you have to think about those things, right? And yes, criteria for selecting routers. So network layer protocols. So what are the protocols it support? What are the routing protocols it support, right? Multicast applications, right? advanced queuing, switching. So a lot of things you have to think when you are selecting the devices, right? And okay, so I think I haven't mentioned the wireless access points as well. So when you are purchasing or when you are deciding the wireless access points, then you have to think about the speeds it supports and the standards of wireless standards it support. You know that we have 802.11a, B, G, N, right? And we have the dual modes, tri mode. So likewise, different standards in the wireless uh, network. So we had to think about those things. And some of these access points, they have their own DHCP is running, right? And so when you have that kind of thing, then so if you need that, if you have that requirement, then you have to go for them. And there are some wireless access points which support VLANs, right? So you have to go for them. And the security features, right? So what is the security standards it support, right? So you know that the WebP is obsolete and WPA, WPA2, WPA3. So likewise, we have different security standards. So what are the security standards it supports, right? So you have to think about them. And sometimes we have to create hidden networks. So which means you have to hide the SSID. So the access point should have that features, right? So and sometimes there may be access point which use the power or Ethernet features, right? So you have to think about all these things. So I haven't mentioned about the wireless access points in the slides. And so sorry for that. So you have to think about that features as well, right? So when you're purchasing the wireless access points. Right. So then we can go to the next part, that is selecting technologies and devices for enterprise networks. Right. So when it comes to the enterprise networks, the one place is that you have to think is the remote access. So that's why I mentioned it in the top. So remote access, because there may be uh, uh, PV users who are uh, connecting from different geographical locations. So the people who need remote access, right? So that part you have to think when you are going to purchase devices or selecting technologies for these enterprise networks, right? So especially when you're selecting these remote access devices, the main thing is the security, and so whether it provides this VPN features, right? So you have to think about it. So that's why I mentioned it in the slide as well, security and the VPN. So whether it support net and the reliability cost, and again the configurations, so whether it is easy to configure, then what are the other technologies it supports, right? And the QoS features. And so you have to think about those kind of things when you are selecting devices for the enterprise networks, especially when you have this remote access, right? Uh, right. So we are in the enterprise networks. So WAN technologies. So it is not the LAN anymore. LAN. So you have to go for the WAN, right? So we have to think about the WAN technologies as well. Okay. Uh, right. Uh, Normally at previous years, I gave some activities from this. So anyway, let's continue the lecture, right? Okay, so WAN technologies. When you are selecting these things, basically you have to think about the bandwidth, right? So it is not only for the today's requirement. So that is the main thing. So you have to predict what will happen in the the next couple of years. So you have to provision, right? So you have to think about the capacity requirement for next 2 or 3 years, and then you have to go for this bandwidth, right? So we have discussed previously about the goals of the organization. So how much it is going to be scalable, right? So we discussed the technical goals and the trade-offs before. So what are the whatever the measurements that you took at that stage? So this is the place that you have to use them in the real world, right? So provisioning the WAN bandwidth. So that is important thing when it comes to the enterprise networks, and you are going to communicate with the WAN, right? So bandwidth requirement. So I have mentioned some technologies as well. The lease lines. So it is, I think you have heard about lease lines. So you have a dedicated line for your organization, and so there are some advantages of that, because you are having a single connection or dedicated connection for your organization, so which will be not shared with other people, right? So unlike the other technologies like this ADSL kind of communication, so you are basically sharing the network with the other people. But when you have a lease line, you have a dedicated line for you. So if you want, you have uh, a, a bandwidth requirement, a very constant bandwidth requirement, then you can go for a lease line, which is a little bit costlier than the others, but it is again based on your requirement. You can go for a lease line, right? And the next thing is synchronous optical networks. So sometimes you might have seen this as SONET. So that is not uh, a new thing, right? This is basically the fiber optic cables, right? The fiber optic communication connection that you can normally get, right? So it provides you this full duplex communication, right? And so that is again another technology, right? You can use the fiber optics. So the Metro Ethernet, ATMs, right? Frame relay networks. So likewise, there are different technologies that you can think about, right? So when you are going to connect with the WAN, right? So these are again different technologies. You can read about these things, and based on your the requirement of the organization and especially the budget, then you can go for whatever the technology that you prefer, right? Then again, so selecting routers for an enterprise VLAN. Uh, so again, based on your analysis, right, of the traffic flow, then you can select the routers, so which provide this necessary WAN interface, so which support that bandwidth requirement. So you can select the routers that you are going to use. So again, in that case, the packet per second values will be uh, required. So you have to check all those things, and you have to check whether the devices has that adequate amount of memory, and whether it has that adequate amount of processing power in the device. So you have to forward a lot of data, and then you have to handle these different routing protocols. So you have to check whether these devices has that sophisticated amount of uh, capacity or the capability inside the devices. So when you're selecting, right? So that is about the routers. So the next one, again, a very important thing, that is the selecting the WAN service provider, right? So because you have to work with a service provider to connect with the WAN. So one of the uh, key criteria here is the cost. So when you are selecting the service provider, normally you have to think about the cost, right? So cost will be one main selection criteria, right? So there are some other things, right, that you have to think. So I have list one, that is the service level agreement. Not only that, so there are some other things that you have to think, right? So what are the services, or what are the technologies that the service provider is going to provide, right? So that is one thing. I guess based on your requirement, you have to think about the services that you require, and you can select the service provider. And sometimes whether that service provider is available in your geographical location. So that is another thing that you have to think. So sometimes the cost might be low and they might provide all the services, but they don't have uh, the coverage for your location. So that is again a problem, right? They might have the lowest cost, or they might provide all the services, but they are not available in your geographical area or geographical location. So that thing you have to think. Then the reliability of the service provider, right, and the performance that they provide, performance of their connection, right, and sometimes the security, right. So security of what they provide, and what else? The technical support, right? So the technical supports are provided by the service provider. So again, all these things has to come from the experience as well. So or maybe the knowledge you get from the environment, right, or from the others. So you might can get some information from the other peers in the industry. So whether the service providers are good to work with them, good to work, right? So what type of technical support that they are going to provide, right? And again, the reputation of this service provider. So you have to think about them as well. And anyhow, you have to check whether they are, uh, I mean, they are happy to work with you. So that is another thing, because somehow you have to work closely with the service providers in some situations. So you have to think about that as well. So service level agreements, I have mentioned it in the slides, right? So service level agreements, it uh, defines some specific terms that they are going to provide. So how they are going to provide their services, and what are the levels, or what are the availability, or what are the performance levels, what is the latency, what is the throughput that they are going to provide. So likewise, they will mention those things in that service level agreements. So that's why you have to measure the network, and you have to check whether they are providing all these this uh, the performance that they uh, mention in the service level agreements. So uh, so basically, these service level agreements, they specify the level of the technical support that they are going to provide, right, and how we are going to communicate with them, right? So whether they have the service 24/7, right? So likewise, these things will be defined in the service level agreements, right? So that is about the WAN service provider. All right. Okay. So that's about uh, 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 the physical design, right? So in this case, it is Basically, you have to implement whatever the logical design that you have developed in the real world. So in here you have that you have to select the devices and the technologies that you are going to implement. So that is kind of a tricky part, right? So anyhow, these things has to be come with the knowledge that you have gained from working in the industry, especially when you are selecting the devices and selecting the vendors and selecting the service providers. So those things has to be come from the knowledge that you gain from working in the industry. And I think you guys have that experience, right? So basically that's it. So that is the things that I wanted to discuss with you. So the first few lectures were about the common idea of why we need this network design, right? And how to identify the goals of the customers, and how we are going to analyze everything, and based on that how you do the communication with the client and come to an agreement that these are the things that we are planning to implement in the network. And after that you go for the logical design of the network, right? So based on the goals and the requirement of the client, are going to design the logical network, and then you will come to the physical network design, right? So once you have completed all these things, so it is, and you will have a working network, the next step is to maintain it or manage the network. So like we discussed in the our last lecture slide, the management is a very important thing. And remember, in all these stages, the documentation part is the most important thing. So once you do all this studying and everything, then uh, mm, you have to do the documentation part, right? So yeah, that's all about it. And from next week onwards, Kenneth will start uh, the take over the session, right? Uh, okay, so for the exam, most probably there'll be more than two questions from my part, and Kenneth sir will give one or more than one question from his part, right? Yes, anything to clarify?
So is it a case study or for the exam?
Yes, I haven't decided yet. So just go through the previous year exam paper because you're the um, I mean proper second batch of this uh, degree program, and last year the course was done by me and Dr. Tabodharan. So there'll be slight changes in the questions because last time Kenneth sir was not there. So my part will be okay, but because Tabodharan, Dr. Tabodharan is not in the team, so the questions from him will be slight different because Kenneth sir will has replaced him, right? Therefore, there'll be some slight changes in the exam paper, so not from my part, but for the other part. Right? So we'll see. So sometimes there will be some case studies as well, not a huge case study, but a small case study. Okay, then, so if you don't have anything to discuss, then we can end the today's session. And if you have any questions, so you can send me an email, right? And I'll try to give my best support. So please complete the assignments. I think you have already done your assignments. So please complete them. I don't think that. So sometimes the Kenneth also will give some assignments. So complete the assignments as well. So if you do not have any questions, so we can end the today's session, and most probably we'll meet in the next semester, right? So next semester we have network security and wireless network security. So there'll be a lot of practicals, right? So not like the network designing course, right? So there'll be a lot more practical thing in the next semester. Okay, so then shall we end the today's session? So if you have anything to let me know, you can tell. So let me stop the recording.
Recording stopped.